Rope selection covers two different stages. First, there's the selection you make when you first go to the shop and you choose the rope you want. And then out on site, or when you're packing the truck, there's the rope selection about choosing which of the ropes you have available are suitable for the task you want to conduct. And for both of those, you need to have a fairly good knowledge about some properties of ropes. So selection describes the process of identifying what qualities of a rope will make it good for a particular task, and then obviously finding the rope that has those qualities. And what do we mean by qualities or properties of a rope? What we're going to be looking at is a few different things that make this rope, for example, very different from this one. And at the highest, the easiest level, you know, we know this is Cougar Blue, and we know this is 3/4 inch 3-strand. So if that's all you know, you're already off to a good start, because you can use the information you have to find out more information. But a good professional arborist knows a lot more about their ropes than that. And knowledge about your ropes is going to help you throughout the life of your ropes. It's going to help you select the right rope. It's going to help you use it properly. You need to know a lot about your ropes in order to inspect them properly. And of course, you need to know when each rope has reached the end of its service life. So let's look at some of the properties of ropes. Abrasion resistance describes the resistance of the rope to damage when it's rubbed against something. So some ropes, for example, this is a 3-strand polypropylene or 3-strand poly, are really well known for having a high abrasion resistance. The individual fibers that make up the rope are comparatively thick, and it's relatively tightly woven. So this is a very suitable rope for things like natural crotch rigging. If I was going to be running a rigging line over this branch, this rope will tolerate it relatively well. So we can say it has a relatively good abrasion resistance. Other cordage like this is a hollow braid, and it's made out of much softer fibers. So it's soft, easily pulled, easily picked fibers. If I was going to use that for a similar purpose for natural crotch rigging, I'd find very quickly that I'm destroying this rope. The same is true of climbing lines. Some climbing lines, for example, 16-strand class 1, has a reputation for having a very good abrasion resistance. So if during your climbing you're regularly setting your lines just straight through a crotch for dismantling, something like a 16-strand class 1 has that higher abrasion resistance. And some of the newer, more technical climbing ropes may actually be a worse choice. This is a class 1 double braid. This one's actually quite good in terms of abrasion resistance, but because it's got it has a higher strand count in the cover, and those strands are a bit finer, you'll find that this rope, if you're using it a lot, running it over a natural fork, without a pulley up at the top of the tree, you'll be seeing the damage appearing a lot quicker. Bend ratio. When a rope is bent over a point, the outside part of the rope has to travel a further distance than the inside part. This concentrates tension in the rope along the fibers around the outside edge of the bend. The larger the bend that it makes, the less concentration of tension and the less reduction in strength. That's described as bend ratio, and it tells us something very important about the use of ropes, particularly for rigging, but also for climbing. So this is a rigging ring. It's a fantastic, simple, new way to reduce force at a rigging point. But there's something very important to notice about it. If I use it with a very large diameter rope, like this 3/4 inch 3-strand, you can see that because the rope is very big, it's having to make a very tight bend around that relatively small point. That's described as having a very tight bend ratio. And used in that circumstance, the force, the tension, is extremely concentrated on the outside fibers in the rope as it passes over that point, and it will significantly weaken the rope. It's important to know that ropes used over a larger bend radius are much stronger. In general, a bend radius of about 4:1. So if the rope was 10 mil wide, the sheave of the pulley over at which it runs should be around 40 mil diameter, are ideal. And some manufacturers recommend not using ropes with bend radii of less than about 8:1. Rope strength is something that arborists often look to when comparing different ropes for a particular purpose, particularly with rigging. But it's actually very important with climbing as well. Rope strength is expressed in a few different ways, and knowing what those both are and knowing the difference is important for selecting the right rope. The two main ways rope strength is discussed are the minimum break strain. So this Donaghy's Cougar Blue here, on the tag it says MBS for minimum break strain, or minimum breaking strength, of 2,800 kilograms. You may also see that expressed in newtons. So if it said 28 kilonewtons, you'd know that was about the same as 2,800 kilos. So that's MBS, and that describes the manufacturer's commitment that the minimum strength it will take to break their rope when brand new is that amount of force. But in some cases, once it's been even just taken out of the pack and used once, the actual break strain becomes a lot less. Because the rope gets dirty, there are little bits of abrasion here and there, which of course creates a weak point in the rope. So if it was tested again after even 2 days of use, you'd find that the break strain was a lot lower. The other number that's important when you're discussing the strength of a rope is the working load limit, or the safe working load. So you'd see that as WLL or SWL. And on this Cougar Blue here, it says 280 kilos. So that's what the manufacturer is telling you. If you want to get the full service life out of your rope, you don't want to have to retire it early, you should keep the load you're putting on it under that figure. So even though the manufacturer is saying you can take this new rope and load it to 2.8 ton and it won't break, or by the time you get close you should start to worry, day-to-day use, you need to keep it under 280 kilos. So that's normally a good amount for climbing lines, and this is a climbing line. That's one heavy person rescuing another with all their gear on the same rope. That's about what we should be aiming for. And the difference between the two, so you'll have noticed 2,800 kilos is the minimum breaking strain, 280 kilos is the working load limit. One is 10 times higher than the other. And that difference, the 10 times higher, that's called the design factor or the safety factor. And for most ropes, if you can only find one of those bits of information, so the rope says MBS 24 kilonewtons, you can assume your working load limit is 10 times lower. So that would be 2.4 kilonewtons, which is about 240 kilos. Design factor is really important because the higher you load your ropes, the harder you work them, the quicker you'll have to retire them. That's called cycles to failure. And cycles to failure describes how, if we've got a rope here that says, brand new, you can load it up to almost 2,800 kilos and it won't break, and you did that, you loaded it to 2,750 kilos, the next time you load it, as you load it, you'll have stretched the fibers, you'll have deformed the rope, and it won't really all settle back to exactly how it was when it was new. The next time you load it, it might break much lower. You might find it breaks at only 1,500 kilos. So arborists who are regularly exceeding their working load limits are putting a lot of stress on their gear. The danger of that, of course, is that large amount of stress means you're now working with an actual braking strength of your gear that's significantly reduced. You no longer know how strong your gear is because you've damaged it. So cycles to failure is really important to remember. Working load limits are really important to remember, and stick to them. We try to keep our loads small, we try to keep underneath the working load limit, and then we're not introducing these weaknesses, we're not degrading the equipment, and we get the full service life out of the rope. Elastic elongation, or elasticity, describes the proportion of its length that a particular rope will stretch under a given load. And you'll see that expressed or written as different ways. You might see it something like elastic elongation 3% at 250 kilos, or it might say elastic elongation 20% at break. But what that's telling you is how stretchy is the rope. And it's quite important for us to know. For example, if you're a climber and you're climbing through the canopy and you've stepped up through a branch and there's a bit of slack in your rope above you and you take a fall, you're relying on the stretch in your rope to do two things. One, it protects you, it reduces the force on you if it stretches a bit, and of course it also protects your high point. So if you're tied in up the top into a comparatively small branch and you take a fall, you really want that stretch so you don't get so much shock load on your high point. And that's why rock climbers use dynamic ropes, they're called. Dynamic ropes normally stretch around 30+% of their length under the load of a fall, and proper climbing lines may stretch as much as 100% of the length. So they'll really stretch out, they'll slow you down over a long period of time. And that's because rock climbers like to climb above their high point, so they're often exposed to a lot of fall. For tree climbing, that would be a real problem. Like an actual dynamic rope in tree climbing would be problematic, because when you lean into your harness, you just keep going. You'd go straight off the side of the branch. So for tree climbing, we normally use semi-static ropes. So pretty much all tree climbing ropes designed for moving around the canopy will be semi-static. But climbers also use ropes that are called ultrastatic. So this is a Spectra Speed. It's got a Spectra core, which is a high modulus polyethylene. It's almost completely static, so you almost can't stretch this at all. It's considerably less stretchy than steel cable. So this rope is very nice to use SRT to ascend on, but if you were using this to climb around the canopy and you had even a small fall, you'd get a lot of a shock and your high point would receive a lot of force. The same is true for rigging. You know, this is a 3-strand polypropylene, and one of the things that make this such a good rope to use for rigging is that it's quite stretchy. When you snatch the head out of a tree, so you're negative rigging, you're dropping a load into it, that little bit of stretch, which comes from a couple of things. It comes from the materials and it also comes from the construction. The rope untwists slightly as it's loaded. That little bit of stretch will help to cushion the blow. So that's elasticity. It's quite important to know the elasticity of your ropes. For climbers, in fact, we don't want you climbing through the canopy on ultrastatic line, and quite a lot of devices specifically say not to be used with this kind of rope. And for people conducting tree dismantling or pulling, recognizing when it's important to use something that's static, that doesn't stretch, maybe like a guy rope as you're pulling a tree over, the last thing you want is for that to keep stretching. And when you want to use stretchier rope, like for when you're negative rigging and you do want to use this 3-strand poly, knowing that kind of information is really important. Getting into more detail, there are lots of properties of ropes that cause climbers and also other working arborists to choose one rope over another. So I'm just going to run through a few of those. Some of the properties are things like the flexibility of the rope, sometimes called the hand of the rope. And you can see this is a fairly rigid rope. Like when I try and tie the knot, it stays pretty loose, and as I load and unload it, the rigidity of the rope means the knot opens. Compare that to a softer, more flexible rope. This is SpectraSpeed. That same rope pulls up it's very flexible, soft cordage, pulls up very tight, and compared to the Ecstatic here, it forms a tighter knot that's less prone to loosening and creeping as I load and unload it. Another property of rope that causes working arborists to maybe choose one over the other is profile. And profile describes the shape of the rope if you were to take a cross section straight across it and look at it from the end on. And this is a 3-strand poly. You can see it's got 3 main strands all just twisted together. So if you were to cut across there and just look at the profile, you'd see something that was very irregular. Something like this is a 24-strand double braid. It's actually got, instead of 3 strands along the outside cover, it's got 24. So if you were to cut it across, you'd see something that was much, much smoother. And there are good reasons to choose one or the other. So for example, I've got that on my Spiderjack here. And a smoother rope with a tighter, more regular profile, like this 24-strand, works really well in this mechanical device. So because I want the rope to slide smoothly through the device, I want something that has a very smooth profile. Something like this is a 16-strand class 1. That's another kind of climbing rope that I could use with the Spiderjack. Might not be such a good choice. Doesn't have quite as smooth a profile. But you might find if you were climbing with a prusik hitch that you preferred this rope. So that's profile and flexibility. Heat resistance describes the ability of the rope to maintain its strength, to not be degraded as heat is applied, normally through friction. So for rigging ropes, that would be where they're turned around a rigging bollard or some other sort of rope break, or maybe where they're running over a fork up in the tree. And for climbing, it's normally as a hitch cord or some other device is run down the rope, a lot of heat is generated. And different ropes have a different resistance to that heat. Some cordage, particularly dedicated hitch cord, has a very high heat resistance. I mean, that's what makes it, one of the things that makes it hitch cord is the ability to withstand the enormous amount of heat built up during climbing. Using other kinds of rope, so rope that's not designed as a hitch cord, can be extremely risky because the heat built up in climbing immediately starts burning through the rope. And I've seen people jump out of a tree on a prusik hitch, step off the rope, and the prusik hitch is almost burnt through. So it's not that you have to know the burn point for every single rope you have, but it is important to know which ropes have a good heat resistance and which ropes have less heat resistance and are not suitable for use in that kind of friction configuration where a lot of heat will be built up. Any bend in a rope, anywhere it's bent over a point or turned back on itself or formed into a loop or kinked, reduces the strength of the rope. Well, it's really important to know for users of ropes to know that and be familiar with it. But what's also interesting is that not all ropes are reduced in strength by the same amount. Some forms of high-tech fibers are significantly reduced in strength when they're knotted. So this is a bowline tied in SpectraSpeed, and we know that a bowline is going to be 60 to sort of 75% of the original strength of the rope. So the bowline reduces the strength of the rope by about 1/3. If this was a 3-ton rope to begin with, tying a bowline in it reduces it down to having a 2-ton break strain. But some fibers, so with some high modulus polyethylene fibers, tying a similar knot, you might find a strength reduction of 50 or more %, maybe as much as 90% with some knots. That describes the knotted strength of the rope. It's also important to think about the spliced strength of the rope. Most splices, so this is a class 1 double braid, most splices don't reduce the strength of the rope too much. They're normally much stronger than a knot. But some kinds of splice, so this here is a locking Brummel splice, tied to make this loop for the X-ring. That locking Brummel is a comparatively weak splice. We might find that the strength of the rope is reduced by the same sort of 30% as the bowline I tied before. The ultraviolet in sunlight degrades the material of ropes. A rope left out in the sun will weaken very quickly. Different ropes have different UV resistance, and if you're selecting a rope for use in Australia, that may be a property you wish to consider. Along with UV resistance, there are different ropes have different ability to resist chemical degradation, so exposure to chemicals like hydrocarbons, like fuel, like oil. But as a general principle, any rope which has been exposed to fuel or oil should probably be retired and certainly shouldn't be used for life support. So we've covered quite a lot of the different properties of rope, and hopefully some of those topics will help you choose the right rope for the right task next time you're going to purchase a new rope, or next time you're choosing a rope out of the truck for a particular job. And how do you go about putting all those things together? Well, for me it starts with having a really good idea of how I'll want to use the rope. So I know that this, I mentioned this previously, this is one of my favorite rigging ropes. What makes it so good is those qualities of abrasion resistance, the right amount of elasticity, sufficient strength, and price. So I can afford to buy a few of these ropes for the cost of one of these. I can do much of the same thing with them. Maybe a little bit harder to work with, a little bit harder to tie and untie. You know, it's a much thicker diameter rope to be coiling up. But of course, I'm also happy to use it just running it over a fork, abrading the rope and replacing it more frequently. So that's one of the things that makes it a good choice of rope for me. And knowing that I'm going to be using it in that manner, knowing that I'm going to be applying the abrasion to it, that I want to use it through a natural crotch during rigging, is what helps me to choose this particular rope when I go to the shop, maybe rather than another one of these. And it's the same with climbing. I mean, if you're starting off looking for what climbing rope do you buy next, we've covered things like the abrasion resistance of the rope. I mean, if you regularly, for doing a lot of dismantling, you spend a lot of your time climbing with the rope on moving a rope system just running through a fork, then abrasion resistance is an important one. If you are using a particular device, for example, let's say you're using the Akimbo, the range of ropes that are approved to use with the Akimbo is very small. In fact, of all the ropes here, the only one that you'd be allowed to use it with is this X-Static. Everything else here is not approved for use with the Akimbo. So that kind of matching the rope to the intended use is important. If you're going to be using maybe just for ascent, just a static access line, the SpectraSpeed might be a good choice. It's light, it's flexible, it's incredibly strong, it's very static, so very easy to ascend with, and completely not suitable for use in work positioning because it hasn't got that elastic elongation to protect you if you take a fall. Again, it's easy to go about choosing your ropes just on, you know, who said what on YouTube, or you've seen someone climbing with it. But you don't know, they may be climbing a very different way, or they may be rigging in a very, very different way. And being able to specify exactly what you want to do with the rope and then choose the right route for the right purpose is part of being a professional arborist.